In rationalization of complex numbers, the very first thing that you should know is complex conjugate. Taking the standard form of a complex number, a plus bi. Complex conjugate of a complex number simply means that changing the sign between the real part and the imaginary part. So a plus bi becomes a minus bi. The same way, if I have a minus bi, the complex conjugate of this becomes a plus bi. Let's take an example. If we have 2, provided we have 2 plus 3i, complex conjugate of this becomes 2 minus 3i. Negative 1 minus 4i. Complex conjugate of this becomes negative 1 plus 4i. Let's say we have 2 plus 3i plus 4x plus 4xi. What is the complex conjugate of this? So the complex conjugate of this becomes 2 plus 3 plus 4x. Okay, so we can factorize this. We can factorize I out. Okay, so changing the sign between the real parts and the imaginary parts becomes 2 minus into bracket 3 plus 4x, then multiplying I. So with the idea of complex conjugate, let's take a last example for this. Given that z equals w exponent 3y plus 2ix, w is equal to x plus 5i. Find the complex conjugate of this. So to find the complex conjugate of this, we already know the value of w as this one. Okay, so we can substitute the value of w into our equation. So that becomes x plus 5i exponent 3y plus 2ix. The complex conjugate of this simply means that changing the sign between the real part and the imaginary part. So that also becomes x minus 5i for this part, and then the exponent to 3y minus 2ix. So this becomes the final answer. So with the idea of complex conjugate, let's go back to our rationalization or division of complex numbers. Taking our standard form, a plus bi. So we divide complex numbers to express them in standard form. In other terms, we try all means of possible to ensure that the denominator does not contain a complex number. Given that z1 equals x prime plus y prime I, z2 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 equals x prime prime plus y prime prime I. So to divide z1 by z2, this becomes x1 plus y1 prime, x1 plus y1 I divided by x prime prime plus y prime prime I. So to do so, we have to multiply through with the complex conjugate of the denominator. Okay, so this becomes times x prime prime minus y prime prime I all over x prime prime minus y prime prime I. Let's take an example to explain further. If we have z1 to be equal to 3 minus 2i and z2 to be equal to -1 plus 4i, find z1 divided by z2. So to find z1 divided by z2, we have 3 minus 2i divided by -1 plus 4. So the very first thing that we have to do is we have to find the complex conjugate of the denominator. We need to find the complex conjugate of the denominator, and then we multiply through with that. And the complex conjugate of our denominator here is -1 minus 4i. So -1 minus 4i. The next thing we need to do is we have to expand the numerator. So we take the 3 and multiply through. That gives us -3 minus 12i. We then take the -2 and multiply through. -2i and multiply through. That one also gives us +2i plus 8 into bracket -1 over our denominator. We already know that anytime we are multiplying a complex number by its conjugate, it's just the sum of the squares of the real number and the imaginary number. So that is 1 squared plus 4 squared. -8 gives us -11, and then -12 plus 2 gives us -10i. So all over 17. So the final answer becomes -11 over 17, and then -10 over 17i. So comparing this to the general form of a complex number, a plus bi, our real number a is -11 on 17, and our imaginary number b is -10 on 17. Let's take more example. So we have another example, 3 over 5i. How do you rationalize this? So in rationalization, the reason or the main motive for rationalization is to ensure that the denominator does not contain a complex number. So by doing so, we have to multiply through with the denominator. So that becomes 3 times 5i over 5i times 5i. That gives 15i over 25 into bracket negative 1. We have the negative 1 because I times I is I squared, which is negative 1. Okay, so this gives 15i over negative 25, which is, so 5 goes into this 5 times and 5 goes into this 3 times. Express eight over 3 plus 2i in standard form. So to express this in standard form simply means to rationalize. How do we do that? So you can go on and try it as I solve with you. So we have 8 over 3 plus 2i. So the very first thing that we have to do is that we have to find the complex conjugate of the denominator. And the complex conjugate of our denominator is going to be 3 minus 2i. So we multiply through with 3 minus 2i. Three plus 2i multiplying 3 minus 2i. So expanding this gives 8 times 3 is 24. 24 minus 16i. And then we've already established that anytime we are multiplying a complex number by its conjugate, it's simply the square of the real number and the square of the imaginary number, the sum of the squares of the real number and the imaginary number, which is 3 squared gives 9 plus 2 squared gives 4. So that becomes 24 over 11 minus 16 over 11 I. So comparing this to our standard form a plus bi, we can see that our a is 24 on 11 and our b is negative 16 on 11. Let's take another example. So note, anytime you are being asked to express it in standard form, you have to give the values of a and the values of b after everything. Let's take another example. 4 plus 2i over 3i. You can go on and solve this. So this gives 4 plus 2i multiplying 3i over 3i multiplying 3i. This gives 3i times 4 is 12i plus 6 into brackets negative 1 over 9 into bracket negative 1. This is going to be negative 6 plus 12i divided by negative 9, which is negative 6 over negative 9 plus 12i over negative 9. So we can simplify this to get 2 over 3 minus 4i over 3. So comparing this to our standard form, a plus bi, the value of our a is 2 on 3 and the value of our b is negative 4 on 3. Let's take our last example. We have 4 over root of 5i. So this becomes 4 times root of 5i over root of 5i times root of 5 times root of 5i. This gives 4 root 5 over root of 5 times root of 5 gives root 5 squared, of which the square root cancels out, and then we have 5 into bracket we then have 5 into bracket negative 1. Which gives 4 negative 4 on 5 root 5i. From a plus bi, the value of a is 0, the value of b is negative 4 root 5 over 5. So that is that for rationalization of complex numbers. If you have any question, you can leave it in the comment section and we will attend to you.